This is a short video explaining the solution for the Networking 1 Week 4 lab on static routing. The requirement is to configure two routers and two PCs such that PC1 can correctly ping PC2 and get a reply. To configure the system, there's three LANs presented. One LAN is to provide IP addresses for PC1 and router 0 to connect. The second LAN is for router 0 and router 1 to connect, and the third LAN is for router 1 and PC2 to connect. To configure the system, we must first assign IP addresses to each of the interfaces on all of the systems to ensure that they can correctly connect from one system to the other. If we review router 0 first, there's two interfaces on router 0 which must be configured. The first one is on LAN 1, which is connecting router 0 to PC1. The first IP address available in LAN 1 is 172.16.1, which is the network component. The first IP address is .1. This is a Class C network, and this is the correct net mask for a Class C network. Router 0 must also connect to router 1, and this will be using LAN 2. So the IP address range that we must use is in the network 172.16.2, and we can assign the first IP address to the serial interface in router 0, which is .1. This is a net mask also in a Class C 255.255.255.0. Router 1 must connect to PC2 using LAN 3. 172.16.3 is the network component, and the first available IP address is .1, and this also has a subnet mask as follows, which is a Class C. The serial interface connecting router 1 to router 0 must be on LAN 2. It must be on the same network as the interface on router 0. This is 172.16.2, which is the correct network. Because we've already used the first IP address, which is here, .1, we can now assign a second IP address, in this case .2. This is a Class C network, and the net mask is provided. For PC1 to connect to router 0, it must have an IP address on the same network that the fast Ethernet has been configured on router 0. So for the controller here, we have a 172.16.1 is the network that we're using, and since we've already used the first IP address in the networking range, we can now use any IP address, but in this case I'm going to use the last valid IP address in this range. This is a Class C network, and we have the same net mask as used by the fast Ethernet interface on router 0. A default gateway is required because this is used when PC1 has an IP address that it doesn't recognize and must have a default location to send that. So the idea is to send all traffic for networks that aren't known to router 0. We send that to the first interface that is available on this network, which is 172.16.1.1, and this is the interface, the fast Ethernet interface here on router 0. For PC2, we assign the following IP address, 16. We are on network 3, as defined here, and the IP address we're going to pick here is the last available IP address in the Class C network. This is also Class C. And the default gateway here is the IP address of the system that should be able to take care of network traffic for networks we're not aware of. So for PC2, the IP address that it will be connected to on router 1 is shown here, which is the default gateway of 172.16.3.1. And that would be all of the IP configuration required for this system prior to configuring any of the routing. Our next step is to open Packet Tracer and to start to build our network. We're going to select components first. We're going to take our first router, which is a 2811, insert that. Take a second system, insert it here. Look for our end devices. We'll take two PCs, insert it here, and a final PC, insert it here. We're now ready to cable the systems. However, first we need to look at the routers. The routers, let me move this into view. The routers do not come installed with a WAN interface. So we can turn off the system, select a WAN interface to install, and then turn the system back on. We need to do that for both of the routers. Select our WAN interface module. We will insert that as follows. You see that if we try and insert one without the power being off, it tells us we can't do that. So we turn the system off. Now we insert the interface and reboot the system. We can now complete the cabling of the system by selecting appropriate cables for each component. To connect a PC to a router, what we need to do is use a crossover cable. We select the fast Ethernet and connect to the fast Ethernet interface on the router. We need to do the same for the following PC. Select the fast Ethernet interface and connect to router 1 on its fast Ethernet interface. To connect router 0 to router 1, we will require the following cable, where we connect from serial 030 and connect to serial 030 as follows. We're now ready to start assigning IP configuration to the system. Our next step is to configure each of the components. So let's start with the first PC. We select on the desktop the IP configuration portion, where we're going to enter static IP address ranges. If we look back to our addressing table, PC1 should have an IP address of 172.16.1.254. The subnet mask is as follows. The default gateway is 172.16.1.1. That should complete the configuration of the PC. We can now move to PC1 and have a similar configuration. If we go to the IP configuration portion, the IP address here is 172.16.3.254, and this is the correct net mask. Our default gateway is 172.16.3.1. Next we're going to configure router 0. I've got two ways to access the command line interface in router 0. I can select it as follows, or I can connect from PC1 using the RS-232 interface to the console line, and then I can go to a terminal application and enter the correct configuration, and also see the configuration dialog from here. The first thing is to enter the privileged executive mode. To go to the configuration terminal, we can set the host name to OR0 as follows. The next would be to configure the interfaces. First interface we're going to configure is the fast Ethernet 0/0, where we will set the IP address as follows to 172.16.1.1. We must set the correct net mask associated with that. Next we bring the line up as follows. Our next task is to configure the serial interface. So we will look at interface serial 0/3/0. We set the IP address as 172.16.2.1 as follows. And we must also identify at this point that the serial line is still down. We set the clock rate, and that won't come up until we configure the far side of the serial interface. But at this point we will have configured, without setting any passwords, router 0. Next we'll configure router 1. At this point I am just going to use the command line interface accessible as follows. We will set the hostname initially, and the hostname will be set to, in this case, all1. We will go to the interface for FA0/0, which connects us to the PC2, and that will be set as follows. The IP address is 172.16.3.1, which is as per our table, and we will set the net mask as follows. Bring the line up using the no shutdown command. Next we will look at the serial interface, which is 0/3/0. Set the IP address, in this case to be 172.16.2.2, and bring the interface up. We now notice that in fact the serial interface is up and will be up from both sides. We can examine the routing table on router 0 and router 1 as follows. In this case we can see we have two directly connected networks to router 0. We have network 172.16.1 directly connected over a fast Ethernet, which is here, and we have a second directly connected network over our serial interface, which is this connection here, and that is network 172.16.2. So as you can see, the router doesn't have information for the 172.16.3 network. And in a similar fashion, if we have a look at router 1, we can see there are two directly connected networks, and it doesn't have information regarding the 172.16.1 network. It only knows about the .2 and the .3 network. So on this point, if we send a ping from router 0, or indeed from PC 0, to the 172.16.3 network, you'll see that in fact we do not have a route to get there. Our next step is to configure routing information on OR0 to identify the network which is currently missing from a routing table. So we will enter configuration mode, and we will set the IP route to 172.16.3, which is the network we're looking to add into the routing table. And we will set the IP address, or the net mask. We will set the interface that this should use, and we can then have a look at our routing table and see we've correctly inserted a static route into the routing table, which allows us to choose an interface to send traffic for the network 172.16.3.0. We also need to go to router 1 and to configure an existing, or to, should I say, add a static route which will identify the network 172.16.1. We will do that as follows. IP route. This is the route we're trying to add to a routing table. This is its net mask, and this is the interface that we will use, 0/3/0. And if we show the IP route, you can see we now have a static route entered for the network 172.16.1. All that remains is to test this by attempting to do a ping from each of the PCs. If I go to the first PC, open the command prompt, do a ping to 172.16.3.254, which is the IP address of the PC, we can see that we now have successful replies, and we have successfully completed this lab.